Zrobisz też? Zrobisz... Okay, microphone is switched on. Okay, so hello after the break. I hope that you had a good coffee break, and now we start with another session. First presentation will be given by Professor Margrethe, and here I'm not sure if I'm pronouncing it correctly, Terklidsen? Yes? Okay, more or less. So, Professor, stage is yours.
Yes, and thank you for the opportunity to present our work here. And it's a collaborative work done mostly by my PhD student, Tobias Kettokat. And he and I is from Department of Food Science of Aarhus University in Denmark. And then we have collaborated with Eva Bydgoszcz, who is from the Animal Biotechnology and Genetics here in Bydgoszcz. We have worked on a literature review on the effect of incubation temperature on chicken muscle and bone development, performance, meat quality, and welfare. And why have we done that? You all know that the world is consuming a lot of poultry meat, and the OECD and FAO, they have predicted that this will continue, that both the production as well as the consumption of poultry meat will increase in the years to come. So in this figure here, you can see how the different meat types will increase both in production and consumption over the next 9 years. And if you just look at the two first columns, which represent the whole world, you can see that poultry is actually the meat species that will increase the most. And this increase and also the consumption that we are doing already is actually challenging the animal welfare of these animals, because the consumers, they want breast fillet. That's what they prefer. So there has been a specific selection for a greater yield of the breast, but not on the leg meat. And that causes an imbalance in the body conformation, increased weight of pectoralis, and it hasn't increased the weight of supporting muscles in the leg. So what we can see is actually leg disorders. We can see an impaired ability to walk, and we can see major welfare issues. As an example, we have done a survey. There has been a survey from Denmark where they have evaluated the gait score of the Danish flocks. And the gait score is a scale where you evaluate the broilers' ability to walk. So if they work without hindrance, they get the score 0. But as soon as you can see that the walking ability is impaired, they will get a higher score. And if they get the score 5, they are unable to walk. So actually a score which is not 0, that implies that there are something which is not correct in their walking ability. So from this figure here, you can see that actually more than 75% in the Danish flocks has an impaired walking ability. And it's expected that this will be the same in a lot of other countries. Why is it so? You can see here we have two versions of the chickens. We have the layers and we have the broilers. And the layers, they have a smaller step width, they have a longer stride length, and also they have a low ratio between the double support versus single support time. Whereas if we look at the broiler and how it has developed over several years, they have a larger step width, they have a smaller stride length, and they spend longer time on 2 legs, which is what we call double support. And all these issues here actually means that the center of motion has shifted due to this tremendous development of the breast fillet. And altogether that causes a lot of energy to stand and to walk, and also they spend more time, and that then means that they spend more time sitting. And while they are spending more time sitting, they don't go to the feed and the drinks, and that's are some of the reasons for an impaired animal welfare. So in 2007, Hammond, Simby, and Stigland, they made a study which could maybe support a way to overcome this challenge on the animal welfare using fetal programming, where they changed the temperature during the incubation. So here's the figure of where the design of the study. They had the eggs were incubated at a control temperature of 37.5 degrees for the first 4 days, and then from the embryonic day 4 to 7, they increased the temperature in one of the groups to 38.5 degrees. And following that temperature, they decreased it to the control temperature again. And one of the things they looked into was the movability, the movements within the eggs of the embryos. And they could actually see already after embryonic day 6 that there was an increase in the movements of the embryo. And that was also visible after embryonic day 7 and embryonic day 11. So it seems like the higher temperature stimulated the movements of the broilers, of the embryos. And then on day 18, they looked into the muscle tissue, and they found that actually the number of myofibers was increased within the treatment group of the higher temperature. They saw more myonucleus, and they also saw an increased weight of the gastrocnemicus, which is one of the supporting leg muscles. So by this study here, it was suggested that an increased incubation temperature in a specific window during the incubation might stimulate cell proliferation and also growth of the muscle tissue. So you can look into fetal programming of eggs where you use thermal manipulation, and you can think of, okay, I can manipulate with the temperature, deviating from the control temperature, which is around 37.5 to 37.8. And you can also manipulate with when do you change the temperature, in which part of the incubation period. So it can be in the early, the mid, or the late stages of the incubation. And what you should be aware of if you actually want to use fetal programming to overcome this welfare issue is that, of course, it should not impair any of the production traits that you want to keep. So it's important that we look into the hatchability of the broilers. We need to look into the chick quality, the sex ratio, as well as the body weight at hatching. And you also want to look into muscle weight, slaughter weight, and meat quality traits, which should not be impaired by this fetal programming system. So we have looked into the literature, what is known on this issue here already. And there are several papers who have looked into thermal manipulation in different windows of the incubation period. And some of them are presented here. I will give an example of one of the studies, which is done by Dalab and Ali from 2019. And they used Ross broilers, and they changed the temperature from 37.8 to 39 degrees in an 18-hour out of 24 hours per day in different periods, and then looked at the effect at day 35 post-hatch. So if you start looking at the first figure, which represents the body weight, here you can see the control is the dark blue column, and then the different treatments is an increased temperature to 39 in the embryonic days 7 to 11. The next is from embryonic day 11. I'm missing a one here. I can see it's from day 11 to 15, and the next one day 15 to 18, and the last one is day 7 to day 18, so the full period. And with the colors, I have indicated that there is a significant difference from the control. So actually, in this case here, they are all different from the control in body weight. But what you should notice is that increasing the temperature from embryonic day 7 to 11 actually increases the body weight significantly from the control. And that is also supported with, if you look into the data on the breast weight and the weight of the thigh, that you can see that in the window from 7 to 11, with increased temperature, you actually stimulate both the weight of the breast, but also the weight of the thigh muscle. Whereas, for example, if you have an increased temperature throughout the period from 7 to 18, it's a detrimental effect. You have a lower body weight and also a lower weight of the thigh. Further, they looked into the diameter of the fibers in the breast and the thigh, and they could see that in the pectoralis of the breast muscle there was no significant difference in the diameter of these fibers, whereas if they looked into the thigh muscles, there was an increased thigh fiber diameter again in this window from 7 to 11. And also throughout the full period from 7 to 18. And then I took the data from this paper here and tried to calculate the relation or ratio between the weight of the breast muscle and the weight of the thigh, because we believe this is actually the big issue on this impaired animal welfare and increased gait score, that there is an imbalance between those two muscles. And you can see that again in the window from day 7 to 11, if you increase the temperature there, you actually get the lowest ratio between those two muscles. And that means that you would expect a larger thigh muscle compared to the breast muscle, which would be beneficial in our hypothesis. Also, we need to look into the performance of broilers who has been exposed to thermal manipulation, as well as the quality of the broilers and also the meat quality traits. And actually, in general, there hasn't been found any impact of the different thermal manipulation on meat quality traits so far. But there are some studies which have identified decreased hatchability, but also impact on the bone quality. So just again an example here, which is from the study of Oxbjerg et al. From 2019, where we used Ross broilers, and we changed the temperature from 37.5 to either 36.5, 38.5 or 39.0 in this embryonic day 4 to 7 window. And we looked at the hatchability, and it was clear that if you lower the temperature, in this case here to 36.5, you had a decreased hatchability, which would be not acceptable. Whereas the other temperatures, there was no sort of impact. Then we also looked, in that study, we looked into the bone and the strength of the bone, because that's also one of the issues that can be part of this impaired gait score, because the broilers have the bones are easily to fracture. So in that study, again, with the increased temperature to 38.5 or 39 degrees, we saw a larger diameter of the tibia, and we also saw that it needed more work to fracture the bone in the 8 increased temperatures compared to the control. So suggesting that actually the bones were more developed in these broilers, and they were maybe more elastic for fracture. So altogether, in this conclusion on this literature review, we state that muscle tissue do respond to the elevated temperature during embryogenesis by proliferation. That means we get more muscle fibers. There is a clear effect on when this increased temperature is put on during the embryonic period, so the timing is important, and that can be explained that we see different expression of regulatory fibers, or regulatory factors, and also the cell lines which develop at different stages in this embryonic period. Breast and leg muscle, they respond differently when different timings are compared. And the leg bone growth seems to be promoted by elevated temperature. The performance is inferior if we decrease the temperature below the control, and body and muscle weights are increased when incubation temperature is in the midterm embryogenesis is increased. And then there are indications that females are actually more sensitive than males to changes in the incubation temperature, and that holds for the muscle changes. And finally, there's no indications from the literature that there's a detrimental effect on the meat quality traits in this as so far. So what we conclude is that you should put close attention to the incubation program, because if you change the temperature to temperatures which is deviating more than 1 to 2 degrees from the control, or if you put this temperature over a longer period than just, for example, fewer days, it does compromise the hatchability and chick health. We believe that we miss knowledge on how this impact of incubation temperature can actually improve their welfare, like walking ability and less bone fractures. And we further think that there is a potential to manipulate with muscle and bone development during the embryogenesis, which should be further explored in order to overcome this welfare issue of broilers without compromising profitability of the production. So with this, I would like to thank you for your attention and acknowledge the support for this project, which has also, other than the EcoSET, has been supported by the EU project from European Union Horizon 2020 Research Innovation Program under the Marie Curie grant with the project Monogot Health. So, thank you.
Thank you very much. Are there any questions from the audience? Okay, I think there are no questions, at least for now. Maybe if anybody thinks about a question, we can come back to it during lunch break. So thank you very much. Now we can move on to another presentation done by Dr. Silvia Travagnello. Am I? Yeah. Professor, yes. Associate Professor. Sorry, Silvia. Okay, stage is yours.
Okay. Thank you, Chairman, and good morning to everybody. Today I would like to present some results of our study carried out in one of the biggest poultry industry in Italy in order to assess the incidence of breast muscle defects, abnormalities in broiler chicken reared and slaughtered under commercial condition. Just a brief introduction of the topic. We know that in the last decades, meat consumption has been shifting towards poultry, and we can say that chicken will be the meat that feeds the people going forward. In fact, world poultry production is expected to increase by over 181 million tons to 250. And much of the increase in this poultry production will be powered by continuous genetic selection. We know that modern hybrid genotype reached the slaughter weight of about 3.5 kilos with an average breast yield of 25% in 1/3 of the time needed from chicken 60 years ago. However, stimulating birds within a short period of time has a downside effect related to the increased incidence of muscle defect and myopathies. These defects are termed as white striping, wooden breast, and spaghetti meat, and are the growth-related abnormalities, since their occurrence is higher in fast-growing genotypes selected for high performance. From the first paper published in 2009, when white striping was firstly recognized in poultry production, up to date we have over 300 papers published about these myopathies. In fact, there is a great interest of scientific community to find a solution to reduce the incidence of these abnormalities, which made a lot of economic loss for poultry industry. Just a few description, or a brief description of these abnormalities, which are characterized by distinctive phenotypes. For white striping is characterized by a white striation of variable thickness, which run parallel to the myofiber direction and characterized at perimysial level of increased deposition of lipids, so a lipidosis. Wooden breast is characterized by the presence of outbulging and pale areas of hardened consistency, and at perimysial level we can see a proliferation of connective tissue, so a fibrosis. while on the opposite, spaghetti meat is characterized by loss of integrity with the separation of the fibers as like spaghetti. And at perimesial level, we can observe a rarefaction of the connective tissue. Despite these abnormalities are characterized by distinctive phenotypes, they share common histological traits. In fact, they are all characterized by a modification of the muscle architecture with the presence of fiber with a rounded profile, joint fiber, hypercontracted fibers, but also infiltration of inflammatory cells, and as I told you before, a compromised perimesial septa. Here, even if the molecular basis of these myopathies are well understood, the causative effect underpinning the onset of these abnormalities are not well understood. In this graph, taken from a recent review of soya, we can see that a lot of events can contribute to the onset of these abnormalities. But the main hypothesis is related to the low vascularization of this hypertrophic growth fiber, muscle fiber, which lead to inadequate oxygen and nutrient supply to the muscle fiber, and leading to hypoxia of the tissue with metabolic modification, which led to later to ultrastructural modification of the muscle. Another hypothesis is the sarcoplasmatic reticulum stress came from the higher protein deposition with the buildup of misfolded protein, which can contribute to the altered calcium homeostasis in the reticulum, and then activation of protease and lipase with the degeneration of the muscle fiber. However, the study are still ongoing to better understand the causative effect which underpinning these myopathies. Now I just would like to focus to our works, which the main aim was to estimate the incidence and the level of these myopathies, white striping, wooden breast, and spaghetti meat. And this study was carried out in one of the biggest slaughtering commercial plant in Italy. And also we evaluate the effect of some antemortem factors, such as genetic type, sex, diet, transport time, and duration of the pre-slaughtering stop on the incidence of these abnormalities. We took in account 79 production lots, and each lot consisting of 200 pectoral muscle, and a visual evaluation of the pectoral muscle was performed to define the presence or absence of the white striping, wooden breast, and spaghetti meat, and define the level of these abnormalities. Just briefly, how we conducted this characterization. For white striping, a visual evaluation was carried out, and three levels of severity were found. So normal, moderate, assigned to fillets characterized by white striation only in the cranial part of the fillets with a thickness lower than 1 millimeter, while severe stage was assigned to breast fillet characterized by a diffuse white striation with the thickness higher than 1 millimeter. The assessment of wood and breast was carried out through palpation, and so we categorized as normal, moderate fillet with just a visible hard bulge in the caudal part, while severe stage was assigned to breast muscle characterized by hard or extremely hard along the entire fillet, with evident pale and exudative areas. For spaghetti meat, also we evaluate using fingers, and so we characterized as normal, moderate breast with poor fiber cohesion, while severe stage was assigned to breast with completely unstructured muscle fiber. Here, just to show the factors that we took in, the antemortem factors that we took in account, divided for two commercial categories. Medium broiler came from medium growing genotypes, and heavy slaughter at a live weight lower than 3 kilograms, while the commercial category heavy broilers came from fast-growing genotype, slaughter at a live weight higher than 3 kilograms. We can see that for medium broilers, we take in account sex, difference growth rate, transport time lower and higher than 120 minutes, stop at the slaughterhouse, and also diet, so standard versus vegetable. While for the heavy broiler, we didn't take in account sex, since all lots were consisting only in male broilers. And growth rate, transport times, stop and slaughterhouse, while diet was exclusively standard diet. And data were analyzed using just one-way ANOVA. Here we can see the frequency distribution of breast weight. We took in account 15,800 pectoral muscle, and we can see that the average weight was about 700 grams. In this graph, we can see that the 34% of the all lots considered were normal, without defects, while 43% showed one moderate defect, and 23% show at least one defect at severe stage. In particular, 16% show one severe defect, 7% two severe defects, and 0.2 three severe defects. This is because it's not unusual to find in the same fillet the abnormalities of white striping and wooden breast, or white striping, wooden breast, and sometimes also spaghetti meat together. In this table is the overview of the incidence of each breast abnormalities. And we can see that wooden breast has the highest incidence. We have about 60% among the two levels, moderate and severe. For white striping, about 30%. And for spaghetti meat, we have about 20%. We make also a correlation among breast weight and the incidence of these abnormalities in the severe stage, and we can see that we have a positive correlation for white striping and even more for wooden breast, while for spaghetti meat we didn't find any significant correlation. Here is reported the table about the effect of slaughter weight. So lower weight lower than 3 kilograms, heavy weight higher than 3 kilograms. And we can see that the incidence of meat defects is higher in heavyweight category, especially for the severe stage. As we can see for white striping, we have 16% versus 4%, while for wooden breast we have 28% versus 11%. While for spaghetti meat, we didn't find any significant difference among the two live weight, slaughter weight. Regarding the sex effect just in medium broiler category, we didn't find any significant difference in the occurrence and incidence of these abnormalities, except for spaghetti meat. We see that females are characterized by a higher incidence of spaghetti meat in the severe stage. This is a little bit hard to explain, but probably is related to the different collagen metabolism in male and female, also related to the hormonal profile, and because, as I told you before, spaghetti meat is characterized by a rarefaction of connective tissue, so there is this kind of relation. Regarding the growth rate, we didn't find any significant effect in both categories, medium and heavy chickens. And also for the transport time, short and long, and pre-slaughtering stop. So in conclusion, we can say that considering the effect of antemortem factor, just the main effect was related to the slaughter weight, as we see that heavy broiler are characterized by a higher incidence of these abnormalities. In conclusion, we can say that this topic is wide, and we are searching for other possible causative effect underpinning the onset of these abnormalities related with alteration in collagen type 4, because we saw from the literature some similarities among not defects, some muscular abnormalities in human with these abnormalities in chicken due to the genetic variants of gene encoding for collagen type. We will see what happens in the future. Thank you for your attention.
Thank you very much. Any questions? Yes?
Yes, we have. Yeah, we see. Yes, because weight is related to age, and here you can see the slaughter age is similar. So just in this case, we see the effect of slaughter weight. But age is one of the factors affecting, yeah.
And then it's incredible to see those pictures, and specifically this about the spaghetti meat. Are there done any studies where they have looked at the live animals? Because I think how can they actually
Yeah. This is a great issue for the poultry industry, and
But has it been spotted on live animals in any case? Do you know about that?
yeah, about welfare and health of chicken. Yeah, is also related. Yes. Thank you.
Just of curiosity, because in Denmark, we are aware of the cases, but it's sometimes not something that industry want to discuss so much, because how is it in your country?
In our country, poultry industry are very interested in better understand this mechanism and how to reduce the incidence of these abnormalities, because for them it's a huge economic loss, because these pectoral muscle are downgraded and used for processed meat, so they have a great economic loss, so they have a great interest to reduce these incidents, and they are open to the collaboration with the university. Okay.
This is the example, industry collapse.
Yeah, to make this.
Yeah, but as long as people don't know about it, I mean, then it's.
Yeah.
Because when you see those like this spaghetti meat, you think those broilers can't be having a nice life, yes.
Yeah. Okay. Thank you. Thank you for your question.
Another question?
Thank you.
Thank you very much. And now we can move to the last presentation of today's session, Professor Majorano.
Thank you very much. To introduce my presentation, good morning to everybody. Generally my presentation is regarding poultry, but in this case will be regarding chicken. But let me say before to start, thank you very much to Professor Bydgoszcz to give to my department and my group to participate to this project, this EcoSET project. Another good experience that we have. Our experience started more than 15 years ago in research and also in friendship. And also, to give us the opportunity to have this lecture and with my student, PhD student. So anyway, thanks, Professor Bydgoszcz. So as you see, I would like to talk about beef. In particular, I have just a little information that the introduction, regarding the nutritional value of meat and its consumption in the world, and also focalize the effect of meat production, beef production in particular, on the impact, of the environment. So some aspects that regarding meat quality, in particular, the relation between, the comparison between the intensive system and extensive system, when animals were already on the grass. And also meat quality that regarding in particular, some points, the shelf life of meat, and also maybe a question if this beef meat really have problem for our health, and some little conclusion. So, first of all, I think when we talk about food from animal origin, that we have essential amino acid in this food, very important, essential fatty acid, also minerals, vitamins. In particular, when we're talking about meat and beef in particular, we have also, it's a very nice resource that regarding, the essential amino acid, many nutrients. In particular, generally, we say to the students that is rich of vitamin 12. Generally, vitamin 12 we can find also in foods from animal origin, and cheese also too, not only meat. But in particular also about iron. Iron is very important in the meat, is available compared to the vegetables. In fact, you say that this publication in Science that say that to reach the recommended, daily intake for the woman, it's generally about 18 milligrams of iron. For reach this, women need to eat 2.5 kilograms of spinach. It's incredible. This means 8 times that the cooked liver, for example. But, meat is very important also for other bioactive compounds, for example, CLA, conjugated amino acid. Somebody said that in some review that the fat is very important too, because it gives the sense of satiety to us, and this means that contrasts the obesity. This, in any way, it's for 30 years ago, the consumption of animal products in low and middle-income countries has more triplified. This depends, of course, the people is increasing, particularly in this area, the population is increasing. Also, it's important because, most people live, from rural area to go to urban area. And also, the gross domestic products is income in this city, in this country. So you can see in these slides where the people is growing very, very fast, in particular in ASEAN, in some country of ASEAN, and in Africa. These people, they want to eat now products from animal origin. They are probably tired to eat every time rice or something like that. So another important point is that you can see that the people move from rural area to go to urban area. And you see that from 1950 to the estimation from 2030, we expect that 60% will live in urban area. And if you consider the estimation for 2050, the 70% will live in urban area. What this means? This means, first of all, that people change the lifestyles. Of course, they changing the diet, modify the diet. And this answer what FAO say many times. FAO say predict that in 2015, the prediction is that the improvement of consumption of food of animal origin. They say that will increase 70% of meat and meat products. Some review, they explain that probably 100%. Increase also the milk and milk products, plus 58%. What about food of plant origin? This food plant origin remains stable. Of course, we're talking about in the world. So, and about beef production. Well, the world production has increased constantly over the last half century. Is one of the most widely consumed protein resource in the world. If you imagine that the population, the herds of cattle is 1.5 billion in 2020, and the world demand of beef was 70 millions of tons in 2019, and will increase to 74 million tons in 2023. But additionally, we have other information. It's very important that in many areas of the world, the beef production, cattle production is economically and socially relevant because represent a valid economic activities in many areas, in mountains, in hill region, where there are not alternatives for agriculture, thus animal production. So anyway, the conclusion about this point is that beef is nutrient-dense food that can be considered an evolutionarily appropriate food from humans. But we don't understand why the global livestock industry is under theater. We know, but we don't understand too much. I would like to explain to you why I don't understand in this case. Of course, we have general criticism. Why about welfare and health of animals? Of course, we know there are some problems, but now the farmers increases the welfare and health of animals. They have very strictly regulation, especially in European country. Drugs and antibiotic resistance is a very big problem, but we have information that in European countries, they reduce the use of drugs. In Italy, from 2018 and 2020, they reduced the 50% of the use of the drugs in animal production. Other things is the husbandry system. Of course, I will talk later about this. And another point is the environmental impact in terms of carbon footprint, water footprint, soil footprint. And another big problem, what I told before, meat and health. The relation between red meat and health is a benefit or risk. I try to explain something at the last point. So, anyway, we start just for environmental impact. You know, the question is eating meat bad for environment? Or if you want, another question is, will we save the planet if we stop to eating meat? So, about meat production and environmental impact. About carbon footprint, you know, the production of greenhouse gases. We know that ruminants produce higher GHG emission, you know, compared to, of course, poultry, for example, in particular beef production, and of course, dairy cattle. But I think you have to consider this new model that the global warming potential start. They say the comparison of emission of CO2 that comes from extraction and use of combustion activity, you know, like coal, oil, natural gas. This CO2 remain permanent in atmosphere 1,000 years. What about the CO2 or maybe methane that ruminants produce? First of all, the permanence in atmosphere is about 10 years. But it's important to remember that the methane that these ruminants produce for natural digestion, metabolize, you know, it was transformed in the time in CO2. This means that CO2 plants utilize CO2 and give food from the animals and give food to humans too. Water footprint, this is another question. Some review reported that in Italy, to produce 1 kilogram of beef, you need approximately 11,000 liters of water. In the world, more than 15,000 liters of the world. But be careful. We have to be very careful. First of all, we don't have lots of study about this. But the point is, when we talk about the water that animal use, in the case of ruminants and beef, of course, we have to consider, you know, first of all, that the water, generally we divide it in green water, blue water, and gray water. The animals, the ruminants, generally use 40% of the water comes from green water. This means that water, if they don't drink this water, we don't use this water come back to the natural cycle. Only 60% is 3% of blue water aquifer, of course, you know, underground water, and 3% is gray water, the water that usually we purify and we utilize again. What do you think about? To produce 1 kilogram of corn, you need more than approximately 2,000 liters of water. And what do you think about? This is not a joke. 1 drop of coffee, from 1 drop of coffee, we need 1,100 drops of water. Of course, you continue to drink the coffee. You know, I don't want to be terrorist. So, another point that I would like to consider, the environmental impact on the diet, particularly the assessed impact of the overall framework on the diet. I want to explain this point, I would like to use the environmental hourglasses. Environmental hourglasses want to see really the impact of balanced diet. You know, we have to consider in this diet that weekly, you know, in this diet, we eat 14 portions of meat, fish, eggs, legumes, cured meat. And I would like just to compare quickly, because the time is not very large, with the 35 portions of fruit and vegetables that we eat in a week. In terms of carbon footprint, kilograms of CO2 equivalent, this means 6.57 for this 14 portion, and this 35 portion of fruit and vegetables means 6.0. Well, the difference is not a disaster. And if you consider the water footprint, 3,500 liters from the 14 portion a week, of course, 3,200 liters for fruit and vegetables. But I think everybody knows that to produce fruit and vegetables, we use herbicide, pesticide. I don't have any comment, because we know the big problem of these things, these chemicals. It's very dangerous for the soil, it's very dangerous for the water, it's very dangerous for us. So I think that consumer now want to know, is necessary that, to inform them about the food they eat, they buy. In particular, about the meat, they want to know if the meat is safety, if the quality of the meat in terms of nutritional impact. It's very, very important, yes, for them. So, about meat quality, I try to answer something to compare, when we obtain meat from animals reared on the pasture, they feed grass pasture, and animals that reared in intensive system. In terms of sensorial meat quality, what we say? The first part, what we say, the meat, produced from the beef that were reared, cattle that were reared on the pasture, you can see, first of all, the color of the meat is absolutely different. The color of the meat when you obtain it to intensive system is poorly lean also, this meat. The meat from intensive system is cherry red color. It is better. Consumer is attracted with color. If we talk about the fat, in intensive system, the fat is white. In pasture system, the fat is yellow. The fat is yellow because we have in the grass a lots of carotenoids. Carotenoids generally in the fresh pasture is around 500 ppm per kilogram of dry matter. If you compare with dried and chopped heavy, is less than 50 ppm. And if you compare with cereals, this means concentrate, when you feed animal, is very low. But carotenoids is not important for give the color to the fat. It's important because it's antioxidant also. So anyway, we come back our point comparison between sensorial meat aspect. Another point very important is that the meat that produced in extensive system is lower tenderness. And also, this meat had higher amount of antioxidant. For example, alpha-tocopherol. In this case, of course, we're talking about vitamin E. So anyway, next point, again, nutritional properties. If I want to describe to you nutritional properties in terms of fatty acid composition, cholesterol, and so on, I need a lot of time, of course. But I will give to you some information very, very quickly. We start, for example, for many scientific evidence. Many scientific evidence tell that meat produced from grass, it's completely better, in terms of nutritional aspects, characterization. I just showed to you some very old information from Raleigh, but we have lots of information that regarding this point, many. I just spent a few minutes to describe what I did in this paper. I am a co-author of this paper, Rule et al. 2000, and this 2002. This paper was cheated more than 207 citation in Scopus. Interesting part of this paper was the comparison between the beef that were fed finished, grain finished, and grass finished. You can see the amount of saturated fatty acid is very lower in grass finished. Higher MUFA, monounsaturated fatty acid, higher polyunsaturated fatty acid, higher ratio polyunsaturated saturated, and lower omega-6, omega-3. So I try to just shortly to describe which is the difference between in terms of nutritional composition between meat obtained from grass and meat obtained from intensive system, from this scientific evidence. First of all, this meat from grass is contain low saturated fat and low cholesterol. Second point, more conjugated linoleic acid and omega-3 fatty acid, abundant in omega-3 fatty acid docosapentaenoic acid, DPA, and this DPA generally was transformed in human, in APA, eicosapentaenoic, and everybody know the important effect anti-inflammatory effects. Also is rich of CLA, conjugated linoleic acid, anti-cancer, anti-adipogenic properties. Is better in terms of the ratio omega-3, omega-6. But that is higher, this ratio is better for health. And also, if the animal eat pasture, this meat gives to us in the blood, in our blood, more amount of DPA and APA. And another point, everybody thinks, for example, that, the phytochemicals is abundant and they are only in the vegetables, in the different kind of vegetables. When animals eat grass, this meat contains phytochemicals. And we know that phytochemicals is very important for our health. It's anti-inflammatory, antioxidant, antiviral, anti-carcinogen properties. This is very important for us to know. Especially the consumer need to know. So now, regarding again the pasture, I told you before that in the pasture we have a relevant source of vitamin E, this very natural antioxidant. We'll see what is the effect. The first of all effect is on the shelf life of the meat. They preserve, the membrane, and they also preserve the color of meat. I give you very easy samples. If you have one stick from beef reared in the pasture and one stick from meat animals reared in intensive system, when you if this in time 0 or time 2, time 3, days, the color of course is better in the stick that you have from the intensive system. But after 7 days, the color changed completely in this and remain little bit stable in the meat that you have from pasture. But another point regarding shelf life of meat. Now, when you go to the store to buy the meat, generally you don't buy 100 grams or 200 grams of meat. Generally, people buy more. They want to save for all week, and it's better, of course, if the shelf life of this meat is better anyway. So I give you very short information about shelf life, about this paper. You can see we have 3 groups very shortly: grass, medium level concentrate, higher concentrate. You can see the level of alpha tocopherol, this vitamin E, is higher, of course, in meat from the grass. But it's interesting to see what happens when you save this meat. According to what I said you before, the shelf life of this meat. You can see that the bars in terms of monoaldehyde, in the meat that you obtained for grass, we don't have any difference, from 0, from 7 aging. But in the meat that was obtained from animals that were reared and were fed with concentrate, medium on higher, you can see that, the shelf life of this meat is drastically reduced. You can see, the difference between the monoaldehyde from this group, time 0, time 7, time 0, time 7. This difference is, of course, significantly. So, about the tenderness, this is another very important point. I showed to you this slide. This slide showed, first of all, that when you have animal in free range, this is Podolian animal. Podolian beef is our local beef. And first of all, in this meat, you have lower saltness. But about the tenderness, yes, of course, this meat is less tender. But we have to do is easy, of course. You can prolong the aging of the carcass. This is a good strategy. Of course, generally in Italy, we aging the meat for 2 weeks, but we prolong 3 or 4. But people say, maybe if you prolong, you have some damage to, maybe to the fat, for example. You increase the peroxidation of the fat. Vitamin E in this kind of meat preserve this oxidation, according to what I said you before. So, grazing breeding system is very important not for this. Give food to the animals, combating soil erosion, supporting biodiversity, capacity to recover degraded areas, and also carbon sequestration, this carbon capture. These figures show to you the importance of the soil in capture, in carbon capture. But another point important is, if you look at this graphic, show to you the the arable land for each people on the world. You can see in 1960, each people in the world have arable land more than 1 acres. This means more than 4,800 square meters. You know, population is increasing, and the arable land decreased drastically. The prevision in 2015 that each people in the world will have less, it's about 1,800 square meters. You know, you have to consider, again, the pasture is very important now, because we don't have arable land. Maybe we reduce the arable land to produce food for the people. You have to consider this point too. It's very important. And also it's very important, maybe associated to the pasture, to think about to use byproducts, co-products, non-human edible resource in terms of circular economy. It's very, very important too. We have many samples in Italy, especially when they use citrus, derived from citrus. Last point. Last point regarding the meat and health, its benefit or risk. You know, many talk shows in Italy, but I don't think only in Italy. Many newspapers, they said red meat equal cancer. But we are sure about this? I am not really very sure. I think that the best point there to consider the cooking method, first of all. The cooking method is very important. I show you this picture, you know, that described quickly what I want to say. You know, of course, when you cook the meat, you don't do this, close to the fire. No smoke, no close to the fire. It's important to have meat a little bit up, you know, from the charcoal. You cover with ashes and you take time, not quickly. This is very important, because the second, this figure that show down, this is very dangerous, because in this case is, you know, generally was produced some carcinogen substance like heterocyclic aromatic amines, but in particular polycyclic aromatic hydrocarbons. This, yes, this is very dangerous for our health. Of course, this happened because we have this reaction that everybody knows, Maillard reaction, a reaction between protein, sugar, and of course, the heat, you know, the temperature. So anyway, we have some preliminary results from our study that regarding the use of vitamin E, the effect of vitamin E, if reduce or not, or prevent the formation of this cancerogenic substance during cooking of meat. So, this experiment is like in vitro. We used, some portion of hamburger. One is control, of course. Other one was like injected. You know, we addend dialpha-tocopherol acetate, different concentration, 2 micrograms, 4 grams, 3 micrograms, 4 and 6. The barbecue temperature was around 200 degrees Celsius, and the internal was 75, and the meat was very cooked. And after we analyze what will happen shortly in terms of total pH. When we use 2 micrograms, we don't have any effect. When you use other doses, reduce the formation of the total pH. But it's important to divide this HPH in light and heavy. The heavy is more stable and more toxic. You can see that in this case, again, when we use it 2 micrograms, we don't have any effect. When we use it more amount, we have very good effect. We reduce the formation of deep substance. So other point regarding the PAH4, also in this case, we obtained that the vitamin E that we used reduced significantly the formation of this substance. When we talk about benzoapyrene, BAP, in this case, 2 micrograms, is not enough. We need more. So the little conclusion is that the results suggested a promising effect of vitamin E in reducing the risk of the health, especially this heavy PAH being more stable and toxic than compared to the light. But maybe it's possible to reduce the risk of formation of cancerogen substances. We have some information from literature that vitamin E works about this. And this confirms our little study, the first study in vitro. We want to continue. We want to continue maybe to use meat and to compare the meat from pasture and meat from intensive system and to see if it's enough to reduce the formation of this substance. Conclusion, it's too long, but according to EU farm strategy, from farm to fork sort strategy, that aims to accelerate our transition to a sustainable food system, I think that livestock production needs to implement future strategy to furthermore reduce the impact on the environment. Of course, everybody agree. In what terms? First of all, to use appropriate animal genotypes according to the rearing system that we want to use. Better welfare, maybe precision livestock farming, and so on and so on. Of course, we need more research about this. So, other point, recommendation. Of course, first of all, it's better to reduce per capita consumption of meat, especially in industrial countries. Second point, public health recommendations are for reducing red meat consumption to reduce the risk of metabolic disease. But however, it's better to consider that they don't consider which kind of meat. Meat is not equal. I'm talking about, again, beef. It's not equal. Depends what kind of management, what kind of rearing system you use. This means it's not clear, this point. And that is likely because the literature on an animal production system and human health, the relation is limited. We don't know too much. We have to continue to study, to compare this kind of meat, that other kind of meat. So, pasture has positive effect on meat quality. Everybody, I think it's clear for everybody. But my point is, every time I discuss with my student, my collaborator, I believe that integration of concentrate needs to feed animal with concentrate. But it's better that the finish period on the pasture where is possible. Because pasture in finish period, maybe 2-3 months before to kill the animals, it's very important because we have this effect from this antioxidant. This means if we have conjugated these two things, we have good performance from the animals and you have good meat quality for consumer. So meat products, meat produced from animal reared in the pasture or feed fresh forage contain more vitamin E that could be preserved the formation of this cancerogen substance formation. But of course needs more study to confirm or to maybe disconfirm. Be careful to fake news. In Italy, maybe one time a week we have this fake news. Everybody's going there in TV and saying, meat is bad, meat. Be careful to fake news. Don't take care of fake news. Another point, extensive and family system must be maintained. In Italy is very important. Because many rural area, people live this many rural area. Because the presence of the human, it's very important, the land protection and also less urbanization, the people stay there. Of course, it's necessary to increase the efficiency of this. And really in conclusion, when we talk about meat, we talk about that thanks to the meat, what this evolutionist researcher is a biologist from University of California, say that when human, when human integrate his vegetable diet with the meat, this was the time that evolutionary turning point of humanity. This was the moment in which the man increased. So, looking this table, according to what I said before about fake news, this table is from Lancet, prestigious, of course, journal. We're talking about meat, we're talking about red meat. Look, diet rich in red meat is not higher risk factor, for the death of the people. Is alcohol, is smoke, first of all, alcohol, diet poor in cereal, and so on and so on. So, I think I would like to suggest myself, eat less meat and better quality. I don't believe in the future of meat is in the lab, absolutely. And the first point that I think I asked myself, what do you think about when we cook this meat? What happened in this meat about carcinogens, substance, or other things? This is question for me the first. Thank you very much for the attention.
Thank you, Professor. Any questions for Professor? Well, for sure, it was really interesting.
It's important they continue to eat the meat. Okay, this is important. Thank you.
Yes, thank you. Thank you very much. So that was the last presentation in today's session. So thank you very much. And we will proceed with the lunch break that will be served shortly on the first floor. So I invite all of you to go and eat something. And also, since we are here, I just wanted to remind you that we have this formal dinner today at 7 p.m. in the city center. For foreign partners, we will have a bus today. It will take you from the dormitory at 6 or 6:15. I will also give you the exact hour just to be sure. And tomorrow there is this Marburg trip. So I hope that you will enjoy it as well. So thank you very much. Professor, you want to say something? Okay, so we can finish the sessions. So thank you very much, and we can go to eat lunch, and then after the lunch there will be a poster session. So you can also have a time and look at the posters. Thank you.